Today I'm testing a 2 kilowatt diesel air heater in real conditions. Not in a van, not in a garage, but in a 7-meter long workshop container that I use for woodworking. Outside temperature is minus 11.9 degrees Celsius and inside the container it's cold. The goal of this video is simple: to show what a 2 kilowatts diesel heater can really do, where it works well and where its limits are. I show everything from unboxing and installation to modifications for outdoor mounting, first startup, and finally a real heating test without exaggeration and without hiding the weaknesses. Let's start with the unboxing. This is the Vivo 2 kilowatts diesel air heater, a 12 volt and 24 volt model with Bluetooth app control and a remote controller, designed for outdoor use. Inside the box, we get a complete kit. First, the main heater unit itself. This is where combustion and heat exchange happen. Let's take a look at the accessories that come with the heater. Inside this box, we have all the additional components needed for installation. First, there is a heat-resistant exhaust insulation sleeve, designed to reduce surface temperature and protect surrounding materials. Next, we have the exhaust muffler, which helps reduce noise from the exhaust gases. The kit also includes various screws, bolts and clamps used for mounting the heater, securing the exhaust and fixing the air and fuel lines. Here is the metal exhaust pipe, which connects the heater to the muffler and routes exhaust gases safely outside. We also get the electrical wiring harness, suitable for 12 volt or 24 volt systems, depending on the power source. This is the fresh air intake filter, which filters the air used for combustion. Included as well is a 60 mm flexible warm air duct, used to guide heated air from the heater into the workshop. And finally, there is a 220 volt to 12 volt power adapter, which allows the heater to be powered directly from a standard household electrical outlet. So overall, this is a complete accessory set, everything needed to install and run the heater right out of the box. Now, let's take a closer look at the heater itself. This is the side where the control panel is installed. The control panel includes the display and buttons, and it also supports Bluetooth connectivity for monitoring and control. The unit is equipped with a carbon monoxide sensor, which is connected directly to the control system and monitors operating safety. Both the control panel and the carbon monoxide monitoring will be relocated inside the workshop later in this video, so the heater can remain mounted outside while all controls and monitoring stay indoors. This setup allows safe operation and easy access without exposing the electronics to weather. Now I'll start preparing the heater for installation. First, I'm installing the mounting legs that are included in the kit. These legs raise the heater slightly and provide stable support inside the enclosure. Next, I attach the fresh air intake filter. This filter supplies clean air for combustion and is designed to be used with outside air only. On the exhaust side, I install the muffler, which helps reduce exhaust noise during operation. The full exhaust pipe will be installed later, once the heater is mounted inside the protective box that I built on the outside of the container. The kit also includes a remote control. With this remote, you can adjust the heater's power level and turn the heater on or off following the instructions in the manual. In theory, this allows you to control the heater from inside the house. In my case, however, the distance is too large for the remote to work reliably, so I won't be using it as the main control method. Now I'm opening the heater. I need to access the inside because the control panel will not stay in its original position. After removing the cover, you can see that the fuel pump is well protected inside a rubber housing, which helps reduce vibration and noise. On the left side, where the power cable is connected, there is a fuse, providing basic electrical protection. On the right side, this is the main electronic control unit. From here, I'll disconnect the control panel cable because the heater will be installed outside. Instead of leaving the control panel on the heater, I'm going to extend the cable and relocate the control panel inside the workshop. This way, all controls and monitoring stay indoors, while the heater itself remains protected outside. The cable will be extended using soldered connections, not plug-in connectors, to ensure reliable operation in cold and humid conditions. Once the cable is extended, the control panel will be permanently mounted inside the workshop. Here you can see how I've soldered and insulated the cables that will run inside the container. All connections are properly soldered and protected to ensure reliable operation. On the outside, I'll add additional protection using small and larger heat shrink tubing, which will also protect the cables against moisture. Next, I mount the control panel inside the workshop. The carbon monoxide sensor is integrated into the control panel and remains attached to it. After that, I reassemble the heater housing. Once everything is closed and secured, I can move outside and install the heater in its final position. Here you can see the enclosure where the heater is already installed. The box is not fully finished yet. I still need to install the front panel, which will also include a small viewing window. This window will allow me to monitor the fuel level inside the heater without opening the enclosure. At this point, I add 2 liters of heating oil to the fuel tank. A 60 mm duct leads from the heater directly into the workshop and serves as the outlet for warm air. At the moment, the combustion air intake is temporary and draws air from inside the workshop. This intake setup will be changed later so that the heater uses only outside air. After that, the exhaust system is installed, routing the exhaust gases safely outside the enclosure. The exhaust remains completely separated from both the air intake and the warm air outlet. The heater is started for the first time using the control panel inside the workshop. The control panel includes a voice notification feature. The sound is a bit unusual, but that's not important as long as the heater operates correctly. During startup, the operating noise of the heater becomes noticeable, which gives a good reference of how loud the unit is in real conditions. From a cold start, the heater needs approximately 4 minutes to ignite and reach stable operation. For a first startup, there is very little visible smoke, which indicates proper combustion. The heater is now set to its highest power level, which is level 6. This control panel also allows temperature-based operation, where the heater automatically increases or reduces power using the internal thermostat. I'll demonstrate that feature later in the video.
This is really hot. Great.
The air coming directly out of the heater is extremely hot, reaching around 110 degrees Celsius, which is about 220 degrees Fahrenheit. This part of the video was recorded today using the updated setup. The outside temperature is minus 10 degrees Celsius and the heater is operating without any issues. This also gives a good reference of the real operating noise level of the heater in cold conditions. At the start of this test, I checked the fuel level and confirmed that after 2 hours and 50 minutes of operation, the heater has consumed approximately half a liter of fuel. The heater is no longer drawing combustion air from inside the workshop. I removed that intake because wood dust was being pulled into the system, which is not ideal. After switching to this setup, I checked whether the heater lost any output power, but the warm air temperature inside the workshop remained unchanged. Most likely, this is because the heater is installed inside an enclosure. The enclosure itself warms up during operation, so the heater is not drawing extremely cold air, even though the intake is fully external. Now, inside the workshop, the control panel shows that the heater has been running for 2 hours and 50 minutes, and the workshop temperature has reached 5 degrees Celsius. Because the container is 7 meters long, the warm air will need to be distributed more evenly. A single outlet near the entrance is not enough to heat the entire space properly. The plan is to route the air ducts upward from the entrance and then along the ceiling toward the center of the workshop. I will also add 2 downward air outlets. One outlet will be positioned above the lathe and the second one above the workbench. This upgrade will be done later, once the remaining materials arrive. Outside, the temperature is now minus 11.9 degrees Celsius, and the heater is still operating without any issues. After 5.5 hours of continuous operation, the heater has consumed approximately 1.5 liters of fuel. Inside the workshop, the temperature has reached 6 degrees Celsius. At the same time, there is a clear temperature difference inside the space. Near the ceiling, the temperature is around 8 degrees Celsius, while at the thermometer position, closer to working height, it remains 6 degrees Celsius. This shows how warm air naturally accumulates near the ceiling, which is why improved air distribution will be important in the next upgrade. To sum it up, this 2 kilowatt diesel heater performs very well for its size. For such a compact heater, the output and fuel efficiency are impressive. That said, it would be very interesting to test a 5 kilowatts or even an 8 kilowatts version, mainly to see how much faster a more powerful heater could warm up a space like this. One of the biggest advantages of this 2 kilowatts heater is the ability to set a target room temperature. Once that temperature is reached, the heater automatically reduces its power output, which results in lower fuel consumption and quieter operation. The heater also supports temperature-based automation. When a target temperature is set, the heater reduces power as it approaches that value, and depending on the temperature offset, it can shut down and restart automatically. For example, if the target temperature is set to 10 degrees Celsius, the heater will reduce output around that point. If the temperature rises to around 13 degrees, the heater can shut off and then restart again when the temperature drops to around 7 degrees Celsius. In my case, this function doesn't work perfectly, simply because the workshop is too large for a 2 kilowatts heater. This kind of temperature cycling would work much better in vehicles, vans, or smaller, well-insulated spaces. The mobile app also allows weekly timer scheduling, which can be very useful. For example, if you want the workshop to be warm in the morning, you can schedule the heater to start early, so the space is already comfortable when you begin working. Overall, this 2 kilowatts diesel heater is a very good solution for maintaining temperature and for long, steady operation with low fuel consumption. However, if fast warm-up time is the priority, especially in larger or poorly insulated spaces, a more powerful heater would be the better choice. I hope this real-world test helped clarify what a 2 kilowatts diesel heater can and cannot do. Thanks for watching, and I'll see you in the next video.